Hello, and welcome to the Smart Academy at the Smart family of cooling products. Today, we're going to continue our series on desiccant dehumidifiers, how they work, how they operate. The main focus of today's discussion is going to be performance. In previous videos, we walked you through a desiccant dehumidifier and showed you how the air streams work and what's happening. And in a second video, we walk you through the startup procedure. How do our specific units work? How do the blowers come on? How does the reactivation heat work, etc. In this video, again, we're going to focus on performance. I'm going to tell you some things about specifically our dehumidifiers and exact performance of our product, but it's relatively generic depending upon what desiccant dehumidifier you're working on. So I'll go through both ours and other people's products as well. Okay, let's get started. In a previous video, we talked about desiccant wheels. We explained that we break a desiccant wheel into quadrants, and in most of our products, we have two opposing airstreams for the desiccant dehumidifier. First airstream is process. This comes from the space we're trying to dehumidify. We blow process air through the desiccant dehumidifier, through the wheel, and we come out with drier air out of the desiccant dehumidifier. We typically use up 75% or 3/4 of the wheel for process. And then the other side we refer to as reactivation or react. It runs in the opposite direction. We will typically heat this air up through some type of heat source. It passes through 1/4 of the wheel, comes out the back end, and we pick up a lot of moisture through the reactivation side of the wheel. Okay? This stays consistent through all the dehumidification, different types of technology we're going to talk about. Okay? Now what I'm going to do is I'm going to take that wheel and I'm going to flip it on its side, and we're going to talk about specific performance, what we want to expect. Okay, so again, we had our wheel. Now I'm going to flip it on its side. We're going to go through those two airstreams again. So we have process air, moving through the wheel in that direction. And then we have reactivation or react air, moving through the wheel in that direction. In very general terms, we want to dehumidify this process air, and the react air is going to have an increase in relative humidity or grains of moisture per pound. Okay? In order to be consistent, when we're trying to rate a dehumidifier, we try to pick a point that we're going to use for all dehumidifiers so that we can have an apples to apples comparison. The most typical entering air conditions that we're going to rate a dehumidifier on is this. It's at 80 degrees, that's in Fahrenheit scale, dry bulb temperature, at 60% relative humidity. Another way we could represent that exact same point is 80-degree dry bulb temperature at 92 grains of moisture per pound. Okay, so our entering air conditions, so that we can be consistent how we're going to rate this machine, 80-degree dry bulb temperature at 60% RH or 92 grains of moisture per pound. So we're going to use that for our process air. And our reactivation air. Okay. Now I'm going to go through what we expect to see given normal wheel performance on the outlet conditions. Okay, so let me walk you through this. So process air comes in at 80 degrees, 60% RH. We go through the wheel and we want it to be drier on the other end. Well, with a 400 millimeter thick wheel, which is the thicker wheel types that are out there, which is the only type Smart Family uses, in typical fashion, we normally see 123 degree dry bulb temperature outlet. Now this could be 120 to 125, but on our most standard rating point, it's 123 degrees. And we typically see less than 10% relative humidity. Our most standard operating point on our 5,000, 6,000 CFM dehumidifier is 9.8%. Or if I wanted to represent that same point in grains of moisture per pound, it's 123 degree dry bulb temperature at 54 grains of moisture per pound. So we have process air, we bring it through the desiccant wheel, it comes out hotter in a lower percent relative humidity and less grains of moisture per pound. Let's specifically walk through the changes in that air so we can see what we're getting out of the machine. So our air temperature has increased from 80 to 123. So it's a 43 degree F rise in air temperature. Our relative humidity has gone down from 60% RH to 9.8% RH. So 50.2% drop in relative humidity, and our grains of moisture per pound has dropped from 92 grains to 54 grains, or grain depression of 48 grains. That's the typical performance that we could see out of it. Doesn't matter if it's our 2400 CFM or 3000 CFM, 6000, 10,000, 15,000 CFM desiccant dehumidifiers. It's all typically close to this performance when we're using a 400 millimeter wheel. Okay. Now let's talk about what happens on the reactivation side. So the reactivation side, we're typically just pulling this from ambient, and we expect the moisture content to increase as we go through the air. Our reactivation side, we're always going to pass it through some type of heat source. There's lots of different heat sources that this could be, but the most standard is going to be an electric heat section. Okay. So we pass the react air through an electric heat section, and it discharges out of the unit. And I'm going to give you some relatively standard conditions that we'll see. Typical temp we might see is just over 100 degrees. Percent relative humidity can vary, but typical conditions is 84% RH. Now here's where it's interesting. Our grains of moisture per pound on the reactivation side goes up to 255 grains. So what happened? The process air, what we want to drop in humidity, absolutely has. Humidity's down, grains of moisture per pound are down. We've really dehumidified this air, and we can see how much moisture has gone into this reactivation air. A couple important things to note is that in order to achieve this performance, we really have to heat up this reactivation air. So it's 80 degrees coming from ambient and just over 100 on the outlet of the unit or the outlet of the wheel. But right after the heater, our target air temp immediately after the heater is as high as 284 degrees. So we have to heat that air quite a bit. Okay. If we wanted to talk about airflow, just to kind of bring the whole discussion home, if we're looking at the most common machine that is built out there for us, which is the 6,000 CFM desiccant dehumidifier, we're typically rating this machine at 6,000 CFM of process air and 1,400 CFM of reactivation air. So that's it. That's the basic performance point. Please stay tuned for more videos. The next series will go through troubleshooting, what can happen with the desiccant dehumidifier, what happens if it's too hot, what happens if we can't or oversaturate this wheel. We'll go through some things we might see in the field. Thank you. Please have a safe day.